Good morning. I hope your quiz went okay for you. And again, as we're moving along through this remote learning, please get a hold of me if you do have questions. Okay, so today's notes are on what are called arithmetic and geometric series. Arithmetic and geometric series. Okay, so what's a series? Well, a sequence, first of all, is a list of numbers. All right, so 2, 4, 6, 8, that's an arithmetic sequence, a list of numbers. If it's an arithmetic series, that is the sum of those numbers. So a series will be just a single number, whereas a sequence is a list of those numbers. That's the difference between a sequence and a series. All right, so there's this old story that goes through, according to legend, this Carl Goss, when he was in first grade, apparently his teacher thought she wanted to keep her little first graders busy, so she told them to add the numbers between 1 and 100. And he very quickly found a pattern and was done within seconds. So what he did was he found that there was a pattern. If you take the 1 plus 100, you get 101. And as you keep doing that, 2 plus 99, that's 101. And what he found was that there were 50 pairs that added up to 101 to get the grand total of 5,050. So that's what an arithmetic series is going to be. And here is the formula for an arithmetic series. So you have, again, the series of a number of terms. So this is the number of terms in your sequence. How many terms are listed out? How many terms do you want to add? Then it takes the first term that you're adding with the last term. So again, this would be what came first. This would be what the nth term would be. So if you wanted to find the sum of 100 terms, well, this would be 100. This is what actually the 100th term would be. And then you divided that by 2. All right, so that's the formula for an arithmetic series. So for example, if you want to find the sum of the first 63 terms, that's what that means. So here are 3 terms of the sequence. We want to know what the sum of the first 63 terms are. So in this problem, again, we are going to need, so we have the series is equal to the number of terms times the first term plus whatever the nth term would be over 2. Well, in this problem, we want to know what the sum of the first 63 terms are going to be, which means that we need to know what is the 63rd term. Okay, we know what the first term is. A sub 1 is 19, negative 19, but we need to know what the 63rd term is. So you are going to have to use your arithmetic sequence, arithmetic sequence formula to find whatever that 63rd term is. All right, so it is arithmetic. So when you're going through these problems, you have to decide whether it's arithmetic or geometric. This one is arithmetic. It has a common difference of 6. So we know that we want to know what the 63rd term is. I know that the first term is negative 19. I have 63 minus 1 with the common difference of 6. And then we can go ahead and calculate what the 63rd term is. Okay, so we calculate that. We get the 63rd term to be 353. So now we have all the pieces to my puzzle, and we can find out what the sum of the first 63 terms are going to be. So I have 63 times the first term, plus the 63rd term is 353, and then I'm going to divide that by 2. So if I took negative 19, added to it negative 13, added to it negative 7, so on and so on and so on and so on, you get the sum of the first 63 terms to be 10,521. All right. Little slight difference on that is what's the sum of the following series. So once again, we have the first term. I this time now have the last term, but what term does that fall in to my sequence? Where does 242 fall in? Is it the 15th term? Is it the 100th term? That's what we need to know, because you need to know what this n value is. Where does that 242 fall into place? Once again, we can use our arithmetic sequence formula. I know that the first term is negative 28. I'm looking for how many terms is that going to be. Well, as I go from term to term, negative 28 to negative 19 to negative 10, I know that the common difference is 9. All right, I do know what the a sub n is. A sub n is 242. I just need to know where that falls in. So that comes into place here. So that would be 242, and then I'm able to solve for n. So I do get n to be 31. So it is the 31st term in that sequence. So now I can plug it in, S sub n, which we now know I'm finding the sum of the first 31 terms. So I have my n to be 31. I know my first term is negative 28. I know the last term in that series is 242, and divide that by 2. So my sum, 3,317. All right, well, we can do this with geometric as well. Geometrics also have a formula. So we can look at my geometric series formula. So the geometric series is the sum of the nth terms is the first term times 1 minus the common ratio to the number of terms over 1 minus r. If you want, you can go ahead and distribute that a sub 1. And we would end up with a sub 1 minus a sub n times r to or over 1 minus r. So again, either of those formulas would work. I said distribute, it's not really distributing, but this value, if it goes back to our geometric series or sequence formula where you have r to the n minus 1, well, you can convert that into just a sub n times r. All right, so next example. So finding the sum of the first 13 terms for the series. So for the sequence, you have a half, a fourth, and an eighth. So when we're finding the sum of the first 13th, again, our formula is our first term, which is a half, times 1 minus the common ratio. Well, 1/4 divided by a half, or 1/8 divided by a fourth, the common ratio is a half to the 13th power over 1 minus a half. All right, now again, be careful on these because you do have to do powers before we subtract, so don't take 1 minus a half and then try to take that to the 13th power. Okay, that's not how that's going to work, so follow your order of operations always. All right, so just basically typing all of that in, you should end up with, as a convert it back to a fraction, you should end up with 8,191 over 8,192. Okay, so the difference between the two formulas is going back and forth on these is that sometimes it's easier to use one as opposed to the other one. This one you do need to know what the nth term is. So, I chose this one because I didn't have to know what the 13th term was. So you could just plug it in. It makes it a little bit faster. Sometimes if you know the nth term, this one may be faster. So again, it's just sort of a choice. All right. So, okay, so we now know the sum. So the sum of 8 terms, the first 8 terms is negative 170,391. Know the common ratio is -4, so we want to find our first. So just plugging that into the formula again. So I know S sub 8. So basically this is telling me that n is equal to 8. I know the sum of the first 8 terms. So that's negative 170, 391. I'm looking for the for the first term, which I don't know. And then I have 1 minus the common ratio, which is a -4. And I do know that I'm taking that to the 8th power. And then I have 1 minus a -4. All right, so again, be careful when you're simplifying all these values. All right, this is equivalent to 5. So I'm going to go ahead and just get rid of that denominator right now. All right, so if I take this value times 5, I end up with a negative 851,955. That's equal to a sub 1. And I'm going to go ahead and calculate this. Be very careful. Again, you do actually want to make sure that you have that negative in parentheses because you are taking that -4 to an 8th power, which is going to make that a positive. So you actually end up with 1 minus that value. So that whole value is going to give us a negative 65,535. And now I can divide. So I'm taking this value divided by that value, and I end up with 13. So the first term in that sequence is 13. All right, example 3. So I'm looking for the nth term for the series where I know the first term, the common difference, and I know the sum of the nth terms. All right, so let's just again take a look at what we got in our formula. So S sub n equals n times a sub 1 plus the nth term over 2. Okay, so I do know this is 440. I do not know n. That's what I'm looking for. I actually don't know, or excuse me, oh, I do know the first term. The first term is 5. I don't know a sub n over 2. All right, well, I've plugged in what I know so far, but I have two unknowns, sort of. Okay, well, remember that a sub n is actually the sequence for an arithmetic series, because I know it's arithmetic because this is a common difference. So let's use that, and I know a sub n is equal to the first term plus n minus 1 times the common difference. So a sub n is equal to 3n plus 2. Now I can use that in my problem. So a sub n is equal to 3n plus 2, and now I can plug that in. All right, so plugging that in, I end up with n, whoops, got my highlighter going there. Sorry. All right, so I got there we go. All right, so n times 5 plus 3n plus 2 over 2. Again, I made a substitution. Goodness gracious, guys. All right, so I made a substitution. A sub n is equal to 3n plus 2. And so now I can solve for n, because I do know that this is 440. Go through the algebraic process. I'm going to cough. Give me a minute. Okay, I'm back. All right, so algebraic process, go through and simplify this. You end up with 880 equals, well, this is 7. So I end up with 3n squared plus 7n. And bam, 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 it's a quadratic. Yeah, that's right. All right, so we have to solve that quadratic. So 3n squared plus 7n minus 880 is equal to 0. And through the magic of pause, I'm going to factor this really quick. Pause, and then I'll figure. And ta-da! There it is. Magically it appears. So 3n plus 55, and then n minus 16. So I end up with possibilities of n being a negative 55 thirds and n being 16. Okay? Obviously, this doesn't make sense because n has to be an integer at all times. So we're never going to have rational solutions for these. And also, you'll never have negative numbers because the number of terms has to be a positive integer. All right. Okay, now we're going to do the same thing. This time I do want to find the sum of the first 10 terms, knowing that it is geometric. So again, in our formula for my problem, I'm going to cough again. All right, so a geometric series, and I'm wanting to find the sum of the first 10 terms. So S sub 10 equals the first term times 1 minus the common ratio to the nth power over 2. So that looks weird. It looks like a 16. Okay, so what I do know in this problem right now is I know the number of terms that I'm looking to find is 10. I do need to know what the common ratio is, but that I can go back to the geometric sequence portion for that. So in this problem, I know that from the fifth term, that's the second term times the common ratio 3 times. So the second ratio times a ratio, or second term times a ratio times a ratio times a ratio gets me to the fifth term. So negative 162 equals 6 times r to the third power. So negative 27 equals r to the third. So I do end up with a common ratio of negative 3. So now I can make that adjustment in my formula. Boop, get rid of that guy. And I'm plugging into its place a negative 3. Again, make sure when you're calculating this that negative 3 goes in parentheses because it's negative 3 to the 10th first before you can subtract the 1 from that. All right, well, I do know the second term. I know the second term was 6, so just by using the common ratio, we'd be able to evaluate or establish that the first term should be what? Yes, negative 2. So negative 2 times negative 3 does give me 6, so I can make that change in this problem. So the first term is a negative 2. And voila, go through the calculation process. Oops, hang on, I made a mistake. I partially an arithmetic and partially a geometric. All right, so this was supposed to be a 1 minus r, where I knew that this was a -3. So I plug that in, -3. All right, so now I'm good to go. So when I go through my calculations, you should end up with the first 10-term sum being 29,524. Okay, I know it's a lot. Moving on, got our next example here. So in a 22-row auditorium, the first row has 25 seats. Each subsequent row has one more. So obviously this one would have 25 seats, this one would have 26 seats, 27, so on and so forth. All right, well, if there are 35 students in a class and the teacher wants the class to occupy exactly which row, or exactly one row, which row could they sit in? All right, now you could go back and through this and, figure it out. It's not that difficult. It's not the numbers are that big, but it's all about the process, guys, the process of solving. All right. So, again, what type of sequence, first of all, is that? So starting with 25, then 26, so it is going up by 1. So it is arithmetic, so it has a common difference. All right, and we know that there are 35 students. So that's what we're looking for. We're wanting the row that has 35 in it. That is your A sub n. So part A, I know that my A sub n is equal to 35. I know that the first row was 25. How many rows gets me to where I need to be, where I know the common difference is 1. And again, that's just a very quick process, and we do get that that is the 11th row. All right, so not too bad. It's 11th row because it was arithmetic. Okay, so Mr. Cooney does not trust this class. All right, must be my 7th period. All right, so Mr. Cooney does not trust this class and would like to sit behind them to keep watch. How many seats does he have to choose from? All right, so it's just sitting behind him, somewhere behind him, behind that class, in a seat of all of those rows that are left in that 22-row auditorium. All right, so what I know is that I'm looking at row with seats of 36, or he could sit in the row with seats of 37, so on and so forth and so forth. All right, until I get to the last row. All right, now if we need to know how many seats are in the last row, well, we could use our little formula there. So I want to know what the 22nd term is, where I know that my first row was 25. I want to know what the 21st row is. So I'm going to multiply that by, so basically I have 25 plus 21. So that gives me my number of seats in the 22nd row should be 46. All right, so that's what that last term is. That's the A sub n term, 46. All right, so I want to know the sum of those values. Okay, so the sum of those values, that we know that it is a arithmetic series. So basically, how many are we trying to find here? We're trying to find the sum of 11 rows, because I'm going from the 11th row to the 22nd row. So starting with the first term, I do know the first term value was 36. There's 36 seats in the 11th row. Multiply that by the first term, and that, oh, you know what? Messed that up. Hold on. Boop, boop, boop. Flip that around. That is the number of terms. So I'm trying to find the sum of 11 rows where I know the first term. There we go. Where the first term is 36. And I know that the last term, so that A sub 22 is 46. And then I would divide that by 2. So calculate all that. So that means that Mr. Cooney would have 451 seats to choose from. All right, last one here. Okay, so we have a company. We'll give Roberto $100. Each sale after that is for $40.50. So then basically he makes 140.50 for the second sale, which then an additional 181 for the third sale, so on and so on. So how many sales will he have to make in a month to earn at least 2,000? You know what, now that I'm looking at this problem, this one's very similar to one that I've already done. So I would like you to actually do this problem for practice, and then you can take a look at the key and make sure that you did that correctly. All right, so your practice work in preparation for your skills check that will be tomorrow is to finish that example, the previous example I just did, example 6 there. So finish that example, and then also these problems for practice. All right. Okay, that is that. Have a good day, guys, and I will talk to you in 2 days with a new video. All right, have a good day.